In this video lecture, you will understand the concept of cross-validation along with the importance of test and train datasets in the context of a machine learning model. Cross-validation, also known as rotation estimation, is a model validation technique for assessing the generalization of results to an independent dataset. Cross-validation is most often used in prediction problems where one wants to estimate the accuracy of the model when implemented practically. In a prediction problem, the model is usually given a dataset of known data, using which the model is trained to make correct predictions. And once this is done, the model is tested on another dataset to cross-validate its training based on the earlier dataset. The dataset used to train the model is called the train dataset, and the dataset used to test the model is called the test dataset. Assume that a dataset contains 100 numbers. In the first round of cross-validation, numbers 1 to 80 will be used to train the model, and numbers 81 to 100 to test the model. In the next round, numbers 1 to 60, and 81 to 100 will be used to train the model, and numbers 61 to 80 for testing. Similarly, 3 more rounds can be done for this dataset. The test datasets for each round would be 41 to 60, 21 to 40, and 1 to 20. The other 80 numbers in each case will be the train dataset. To code, we can use the cross_val_score function from sklearn.model_selection to perform cross-validation. The parameters to the cross_val_score function are the estimator algorithm, the predictor variables, the target variable, and the number of folds or rounds of cross-validation. The cross_val_score returns an array of scores for each run of the cross-validation. The average and standard deviation of these scores gives us a stable estimate of how the model will perform on unseen data. In the upcoming units, your concepts will be tested through a couple of multiple-choice questions, after which there will be a Python notebook to implement the cross-validation technique.